Hello everybody, this is going to be the last video in our Unit 4 notes. This is going to be 4.6 special segments and triangles. We are going to be talking all about triangles today, and we're going to be talking about certain things that you have seen before, like an altitude. You've seen a median before-ish, but we didn't necessarily call it a median. And then there's going to be a couple of new things that we're going to be talking about today. Some of these things are very basic. Some of these things are a little bit more complicated. And then we're going to move on to our triangle inequality theorems, or the triangle inequality theorem, excuse me, and then just some various pieces of information regarding triangles. Okay, here we go. First thing we're going to talk about is a mid-segment. A mid-segment consists of two midpoints of two sides of a triangle. So what's going to happen is I'm going to say that this right here is the midpoint of AB. Well, if it's the midpoint, that means that it's going to cut this into two congruent segments, right? We know what midpoints are. And then I'm going to say that this over here is another midpoint, which means that B and that center point in C are also going to be congruent. So this thing right here, this line that connects them, is known as the midsegment. So this right here is my midsegment. And it says the midsegment is parallel to, we got parallel to and half of the length of the third side. So I've constructed a midsegment. This is important. It's half of the length of the third side. So your midsegment is always half of the side that it's parallel to. So for example, if my length down here, AC, was 20, then the midsegment would be half of that, which is 10. That's a midsegment. We love midsegments. They're nice and easy. All right, an altitude. An altitude is a segment that passes through the vertex of a triangle and is perpendicular to the opposite side. This one's nice and easy. So when you have an altitude is always going to be a vertical line, always. And this altitude is always going to be perpendicular to the side that it touches on that triangle, okay? Altitudes and medians look very similar, but they are not the same thing. So you need to remember that altitude is straight up and down, it's always vertical, and it's always going to be perpendicular. A median, on the other hand, is a segment that connects a vertex to the midpoint of the opposite side. So if I were to look at this triangle, I would say that this point right here is the middle or the midpoint of DF. So the median that I draw is going to connect that midpoint to the vertex of the triangle from above, okay? Your median is not always perpendicular. Sometimes it will be. If we have an isosceles or an equilateral triangle, then the median will be perpendicular. However, in a lot of triangles, the median is not perpendicular. The altitude is always perpendicular. So you really need to make sure that you know the difference between an altitude and a median, because they are different, they look different, and they do a couple of different things. Sometimes you can have a median that's also an altitude, but not always, okay? So just be careful. All right, centroid, yay. The centroid of a triangle is the point where three medians intersect. So let's remind ourselves what a median is. A median is a segment that connects a vertex to the midpoint of the opposite side. So here we go. This is the midpoint of this line. Here's my median, okay? Over here. This is the midpoint of this line. Here's the median, okay? Over here, this is the midpoint of this line. Here is the median. Do you see that those three medians connect in the center? Okay, that center point right here is known as our centroid. Okay, your centroid, this is information right below it. It says the centroid cuts each median, so each of those purple, green, and pink lines, into a 1:2 ratio. We can use this ratio to find requested lengths inside of triangles. So what does it mean that it cuts it in a 1:2 ratio? Well, we talked about ratios before. Anytime you see a ratio, essentially that's going to be a 1x and a 2x, okay? The short part of your median is always your 1x. The longer part of your median is always your 2x. So here's our 1x, here's our 2x, here's our 1x, and here's our 2x. Okay, so the short side of the median is the 1x, the longer side of the median is the 2x. And then together, that's going to be a 3x. The median itself, the whole median, will be a 3x. That's important. Okay, we got to think about that. So this tells us that BG is going to be 8. I need to find GE, and then I need to find the whole median, okay? Now, if you look at this median, hopefully you can see that this is the 1x side, which means that this one over here is the 2x side. Well, if BG is 1x, that means that x is going to be 8. So how do I get the 2x side? Well, I just multiply 8 times 2, and you get 16. So GE is 16 centimeters. And then BE is going to be both of those segments together. So 8 plus 16 is going to be 24. So this will be 24 centimeters. Okay. Okay. Here we go. CG is 8. I need to find GF and I need to find CF. If you look at this particular median, this side is actually 2x and this side is 1x. So if our 2x side is given as 8, that means that our 1x side is actually going to be 4 because it's going to be 2 of the ratios. So it's got to be 4. This is going to be 4 centimeters. But then I need to know what CF is, the whole side. That's going to be 12 centimeters. Bear. My dog is licking his paws and it's disgusting sounding. Bear. Stop. Okay. AD. Ooh, AD is the whole segment. Goodness, that's going to be 15. So what I need to do now is I need to cut this into my 2x and my 1x. The problem is that the whole median is going to end up being a 3x. That's going to be helpful for me because that's going to allow me to find my 1x. And once I know my 1x, I'll be able to find my 2x. So if 15 is my 3x, that means that the x itself is going to be 5. Well, if x is 5, that means that 2x is going to be 10. And isn't it true that 10 and 5 is 15? So AG, which is my longer side, is going to be 10 centimeters. And DG, hold on, Evers. DG is going to be 5 centimeters. Okay, lastly, we are going to, oh my gosh, madness in here. Okay, the last thing that we need to talk about is AC. Now, if we look at AC, AC is not a median. It's actually just one of the sides of my triangle. And because I have a centroid, that means I have a bunch of midpoints, okay? So I know that AC, the whole side is 8 centimeters, which means that I have to cut it directly in half. So each of these are going to be 4 centimeters and 4 centimeters, okay? So the outside of your triangle doesn't work exactly the same as the centroid does, so just keep that in mind as you work through centroids. All right, moving on. Triangle inequality theorem. The triangle inequality theorem states that the lengths of the two smaller sides of a triangle must be greater than the largest side of the triangle, meaning that your A plus B must be greater than C. If you do not have A plus B is greater than C, then you actually cannot make a triangle. Super important. So we're going to look at these examples and we are going to determine if we can make a triangle. So what I need to do is I need to figure out what my longest side is. That will always be my C side. C, like the letter C. Okay? So this is going to be C, which means that 4 and 6 are going to be A and B. And it doesn't really matter which one is A and B. It just, they're the two smaller sides, right? So you are going to add your two smaller sides together and they better be larger than the largest side. Well, this one gets me 10 is greater than 10. Those lengths do not make a triangle. Moving on to my second example, this is my C, which means that these two will be my A and my B. When I add that together, it better be bigger than my largest side. That's going to be 14 is greater than 10. Yes, this will make a triangle. It does say draw the scenario, but I'm not going to do that because I'm lazy. All right, looking over here, our largest side is actually on this side now. That's my C. So I'm going to add my 3 plus my 6 together. It better be greater than 12. That's 9 is greater than 12. That's not true. So those links will also not make a triangle. Okay, so that's all you have to do to determine if you have a triangle. That's really easy. But what happens if I only know 2 sides of my triangle and I don't know my third side, and I have to make sure that whatever that third side is still makes a triangle? That's what this example is, number 3 here. It says, if you are given the side lengths of 6 and 15, we need to determine the possible range of values for the third side of the triangle. And we're going to always have two scenarios here. So scenario 1 is where 6 and 15, and I don't know what this one is. But in scenario 1, 15 is actually the longest side. That's scenario 1. Scenario 1 is 15 is going to end up being my largest side. So in scenario 1, I know that 6 plus x should be greater than 15. I'm going to subtract 6 on both sides, and I get that in order for this triangle over here to remain a triangle, my x value needs to be greater than 11. And I'm going to circle that. I'm not done because that's just my first scenario. Actually, instead of circling it, I'm going to bubble it. We're going to bubble. Sorry if you hear a child crying in the background. It's my son. He's fine. He doesn't want to go to bed. Okay. Second scenario. Same thing. We got 6. We have 15. We have x. Now, what if x ends up being the bigger side? Well, I've got 6 plus 15 needs to be greater than x. That's going to be 21 is greater than x. And then what I'm going to do is I'm going to take both of those inequalities that I got, so this one, and I have to put them together into a compound inequality to show all of the possible values that x could be in order for this thing to be a triangle. So this says that x has to be bigger than 11, but x can't be bigger than 21. So we have 11 is smaller than x, which is smaller than 21. And this right here would be my final answer. Now this one actually does have units, so I should stick units in there, but that's how you would do that problem. Okay? Draw your two scenarios, get your two individual inequalities, put them together into a compound inequality. All right, we're moving on. I'm moving fast. This next part says, the smallest angle of a triangle is always going to be across from the shortest side. The largest angle is always going to be across from the longest side. So what we have to do is we have to figure out the angles from the largest to the smallest. So what I want to do is I want to focus on the side lengths. Okay? When you look, 6 is the smallest side, which means that the angle across from it is going to be the smallest angle. So the smallest angle is S. So angle S is the smallest. It says go from largest to smallest, which is why I put S all the way over there. Okay. The middle side length is 7, which means that the angle opposite of it, Q, is going to be the middle length. And then 8 is the longest side, which means that R is going to be the biggest angle. So this is the largest angle, and then we go to the smallest angle. The same is true going the opposite way. So the largest side goes with the largest angle. The largest angle would go with the largest side. So it's just the opposite of what we just did. Okay, now we want to list the sides from shortest to longest. All right, we got to figure out some angles here, guys. Okay, I know that these are going to be supplementary. Look at that, our supplementary angles don't go away. So let's calculate this out. We've got 180 minus 120 is 60. So this angle is 60. We've got 180 minus 121. This angle over here is 59. I do have me a good old triangle, so I can do 180 minus 60 minus 59. That is 61. Okay. Now, knowing that, I know the size of my angles, so I just have to match them with their opposite sides to know which side is the longest, which side is the smallest, and which side is the medium. Okay, so here we go. The shortest side will be across from the smallest angle. So for us, that's going to be this side over here, and that is side TU. Then I'm going to move over to the middle angle. This side over here will be my middle side, which is UV. And then my longest side is going to be across from my largest angle, which is this side right here, which is my favorite. It is TV. Okay. The very last thing I have is something called the hinge theorem. It's going to say a lot, but I promise I'm going to make it easy for you. If two sides of one triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Woo! All that's saying is if you have triangles that share sides, so for example, these sides are shared, okay? We know based on the reflexive property that they share this side, okay? If that's true, if you have two triangles that share two sides, then in order to figure out which of the third sides is the longest, we just have to look at the included angle. So here we have 28, here we have 27. 27 is smaller than 28, 28 is biggest. So that means that this side over here is going to be my biggest side. So side AB is greater than side BC. Looking over here, we can say the same thing that we just said. Here's the reflexive property. Here we've got this side matches this side. We need to figure out that third missing side. This is 32. This is 31. 32 is bigger than 31, so that means that QT is larger than RS. So don't let that wordiness scare you. I promise it's not that scary. Anyways, if you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Adios.